Hi guys, welcome to my YouTube channel, and in this video I will discuss about oscillatory motion, in which I will briefly discuss about many examples related to oscillatory motion or periodic motion, in which I will consider that when a spring of mass m is suspended by a force or is suspended by a fixed point, in which when a force is applied it will oscillate with, around its mean position, and its mean position is from above and below of its mean point. This m is known as mean point, and it is also known as to and fro motion. So this is only happen when force is applied on the spring. In addition, in the case 2, when a simple pendulum of mass m is stretched with a thread of massless thread or inextensible thread of mass m, then when force is applied and it will oscillate from its mean position. First it will go to the extreme position, after that it will go to the mean position following the to and fro motion, and this is all these examples are the oscillatory motion. So with this example, or these are the definition of oscillatory motion as well as vibratory motion or periodic motion as well. In these example I have briefly discussed about oscillatory motion with respect to their movement and with respect to their motion and examples. Now I will briefly discuss about simple harmonic motion or SHM. In this example, in order to explain this, a horizontal mass spring system is attached with a fixed point. When the body is at rest, then it is a mean position, or it is a frictionless or restless spring. When a force is applied, it stretches to some extent or some distance. The distance covered by the mass due to stretching by force is known as x. This x is the distance or displacement, and according to Hooke's law, the force applied produce a displacement. So this displacement is equal to directly with relationship with the force F is equal to kx according to Hooke's law, and k is a constant which is known as spring constant or stiffness constant of spring. In addition, when this body is released, so it will go towards its mean position, but due to restoring force it cannot stop at the mean position and compress more, and it also cover a displacement of x. So according to restoring force, so F is equal to minus kx, because the restoring force body will go towards its mean position, and the negative sign of the force, negative sign in the direction of force, F is equal to minus kx. This minus indicates that the due to the restoring force body will go towards its mean position. In addition, we can also know that Newton's second law of motion, F is equal to m into a. So when force is applied, body can accelerate of having mass m. So according to Hooke's law, F is equal to minus k of x. I previously discussed that, and when we equating these two equations, because these two forces are equal according to acceleration and Hooke's law, ma is equal to minus kx. So in this expression, mass and k are constant value, we can replace this and join together, and we can also calculate the value of acceleration due to with respect to displacement. A is equal to minus k over m into x. So at this point we can say that acceleration is directly proportional to displacement with a negative sign, because k over m is a constant value, mass cannot be changed. So a is equal to minus k minus a is directly proportional to minus x. So this definition shows that simple harmonic motion, it means when a body is accelerating, having a simple harmonic motion is directly proportional towards the directly proportional to the displacement, and its movement is directly proportional to the mean position or directed towards the mean position of the body. So this is known as simple harmonic motion, and its acceleration or movement is directly proportional to displacement. If displacement increases, it means that its acceleration is increases, but the negative sign shows its direction towards the mean position. So furthermore, we will also discuss about all the scenario of horizontal spring system in the simple harmonic motion. In addition, we can also discuss many definitions related to periodic motion and oscillatory motion, in which the example of simple pendulum, when the force is applied on the ball of the bob, so it will rotate from its mean position, and it will move into and fro motion. One complete revolution make a one time period or one revolution. So one time period is directly proportional to number of cycles, and is inversely proportional to frequency or one vibration, or one complete cycle is known as one vibration of simple harmonic motion and of a simple pendulum. In addition, this example holds for spring constant or spring mass spring system. In addition, we can also discuss about the angular velocity with respect to time period and frequency. So angular velocity is inversely proportional to time period, because one complete revolution or circle contains 2 pi distance and divided by time. So angular velocity, we can, if we replace or separate the value of 1 over t, we know that value of 1 over t is frequency, and angular velocity is directly proportional to frequency. So omega is equal to 2 pi f, and we can use this formula in other examples. And up till now we have finished about the simple harmonic motion, periodic motion, as well as the vibratory motion in this lecture. Up till now we have finished. If you like our video, you can subscribe our channel for more videos, or if you want to ask anything, you can comment in the comment box. I will reply as soon as possible for you, for your training and for your examination preparation. See you soon. We will see you in the next video. Bye bye. Stay tuned, stay home.